Okay, hello everyone, welcome back to my maths homework. Let's do some questions now. So the first question says that if a1, a2, all the way till an are positive numbers, prove that a1 upon a2 plus a2 upon a3 plus a3 upon a4 all the way till an upon a1 that should be greater than n. So this can be done easily using the am greater than or equal to gm inequality. So the am greater than or equal to gm inequality says that suppose you have some numbers. Say you have x1. Oops. Okay, so suppose you have some numbers, say x1, x2, x3 all the way till xn. Then the sum of these numbers, I'm just gonna call the sum of x upon the number of these numbers, which is n. Okay, so this goes from 1 to n, right, from I equals to 1 to n. This is always greater than or equal to the square root, the nth root of the product of these numbers, which is basically x1, x2 all the way till xn. Okay, so that's what the am greater than or equal to gm inequality says. So we are going to use it over here. So you can see that these are the individual terms, right? The sum of these should be greater than or equal to the product of these, like, yeah. So we're going to apply that inequality over here. So if you divide this thing by n, that will give me the am of these things. Okay, and that means that if you divide this by n, this here it should be 1. Okay, so basically we have to prove that this thing a1 upon a2 all the way till an upon a1 divided by yeah, you have n of them, that should be greater than or equal to the nth root of their product. So a1 upon a2 into a2 upon a3 all the way till an upon a1. You can easily see that this is going to cancel out completely, so that just gives me 1. So it is greater than or equal to 1, which means that this sum should be greater than or equal to n. No problem, easily done. I just delete this. Okay, so let's go to the next question, which says that prove that 1 upon e plus 1 upon b plus 1 upon c is greater than or equal to 1 by square root of bc plus 1 by square root of CA plus 1 by square root of AP. Okay, so what I'm going to do is that I'm okay, and ABC are positive, fine, which means that the reciprocals are also positive. All right, what I'm going to do is that I'm going to break it in half. Okay, so I will write it as 1 upon 2A plus 1 upon 2B plus 1 upon 2B plus 1 upon 2C plus 1 upon 2C plus 1 upon 2A, so that I can pair some stuff. Okay, and now I'm going to use this inequality on every pair. So suppose we use it on this pair, that will give me that this is greater than or equal to uh, what do we have? We have 2 times the square root of these two. All right, or maybe I can view it as 1 by 2 of 1 by a plus 1 by b, which means that it is the am of 1 by a and 1 by b. So this is going to be greater than or equal to square root of 1 by a into 1 by b, which is 1 upon ab. And then similarly this is greater than or equal to the square root of 1 upon bc, and then the square root of 1 upon ac. So now we will just add them up, and uh, yeah, the resultant would be this thing. So it will be like 1 by a 1 plus 1 by b plus 1 by c, that will be greater than or equal to the sum of these, which is this thing. So yeah, that's easy. Let's go to the next question. Okay, so the question says if a is greater than b and n is a positive integer, then prove that a to the power of n minus b to the power of n is greater than n times ab to the power of n minus 1 upon 2 into ab. Okay, that's weird. Okay, it's greater than n times ab raised to the n minus 1 upon 2 power into a minus b. I was not expecting this. Okay, how do we do it? Okay, so maybe like that, it can work. You got that a minus b over there, maybe you can factor out and cancel it away. So yeah, that might work. So basically what it is telling us to prove is that uh, yeah, e to the n minus 1 into b plus a to the n minus 2 into b squared plus a to the n minus 3 into b cubed, oh shit, into b cubed all the way till a to the 1, okay, a to the first power times b to the n minus 1, all okay. So that should be greater than n times eb to the n minus 1 upon 2 power n times eb to the n minus 1 upon 2 power. Well, how many terms are there in this? And we need ab every time, right? Okay. Oh, this is easy. This is easy. Okay, so what I did was that I factored this out and then I cancelled this a minus b factor from both of these sides because a minus b is a positive number. Okay, and that gave me this inequality. Okay, now we have to prove it, which can be done easily if you look at these numbers. Like these can be paired up. Okay, these can be paired up, so you will have something like a the second power, come on, a to the second power and b to the n minus 2 over there, that will pair up with it with this thing, right? And then this will pair up with the next thing, so all of them, they will get paired up, and then you will have that this thing is greater than or equal to uh, 2 times the square root of this, and that will be, okay, that's gonna be like that's not n minus 1 though, uh square root of those two is like their product. Okay, their product, it's not supposed to be n minus 1, is it? No, it doesn't look like that. I don't know what's going on. Okay. Oh, that's why it's not working correctly. It's not supposed to be this thing. So like yeah, it's supposed to be 8 to the n minus 1, then this is times b, then times b squared all the way till a, and there's nothing over there, there's just 1 over there. Okay, that is how it should be. Yeah, that's what you get when you factor this out and then you cancel a minus b from it. Okay, nice. So now we are going to use amgm on these two pairs, so that will give me this greater than or equal to 2 square root of a times b to the n minus 1 power. Similarly, we will use am greater than equal to gm on these two pairs. That will give me 2 square root of, once again, a times b to the n minus 1, and then this will keep on going like that. How many of terms do we have? Okay, so I don't know how many terms do we have. So you got a to the n minus 1 something. Oh god, how many terms? Well, it's going all the way from 1 to n minus 1, right? It goes from 0 to n minus 1, so there should be n terms throughout this. Okay. What is going wrong? What's something not correct? Oh yes. Okay, so eigenvalue says this 2 can be written as root of a times b to the n minus 1 plus root of a times b to the n minus 1. So for each of these terms you have one of these terms. Okay, and then there are n of these terms, so which means you will have n of these terms, square root of a times b to the n minus 1 thing. So this will be, in short, oh god, greater than or equal to n times the square root of ab to the n minus 1, which is exactly what we had to prove. So that's nice. That is really nice. I like this. Okay, let's go to the next question. The next question is, prove that 2 upon b plus c plus 2 upon c plus a plus 2 upon a plus b is less than 1 upon a plus 1 upon b plus 1 upon c. Oh, How do we do that? 2 upon b plus c. Maybe you can use am greater than or equal to hm on this. Yeah, that should work most likely. Okay, we have to think. Just think for some while. It can be like negative, but that won't make sense. That is not something which we should be doing. Okay. Oh yes, it is like that. Okay, so we are going to use am greater than hm on this thing. Okay, so abc are distinct and they are all greater than 0, which means that there is no equality over here. So we are going to assume that this thing is like sums of AMs, and then this thing is the HM of something, this is the HM of something, this is the HM of something. So I'm going to write this thing as, well, you will have it as half into 1 upon A plus 1 upon B plus half into 1 upon B plus 1 upon C plus half into 1 upon C plus 1 upon A. Now I'm going to use AM greater than or equal to HM on each of these things. Okay, so this is the am of 1 upon e and 1 upon b, which is going to be greater than or equal to hm of 1 upon a and 1 upon b here. So that's going to be what? It's going to be like 2 upon the reciprocal. Yes, wait a second. Hm of these two. So suppose 1 upon a and then there is something h, and then 1 upon b. These are in harmonic progressions, which means that a 1 upon h and 1 upon b, sorry, and b are in arithmetic progression, which means that 2 upon h is equals to a plus b. So h will be equal to 2 upon a plus b, right? That should be correct. So their hm will be 2 upon a plus b. Nice. You got 2 upon a plus b over there. Similarly over here you have 2 upon b plus c and 2 upon c plus a, which is exactly what we had to prove, right? And it is not going to be greater than or equal to, because they can never be equal if they are distinct. So yeah, that's it. That's how you do it. Okay, just delete this. Okay, so the next question is, find the minimum value of 2 power sine x plus 2 power cosine x. How do we do that? Well, sure, we could do that thing, but it's not a good thing to do. You know what? No, that won't work as well. There has to be something. So we have to find the minimum value. Okay, so you should have that squared, I guess. Oh yes. Okay. Yeah, let's just do it. Let's just do it, right? Oh, okay, nice. So this thing, 2 power sine x plus 2 power cosine x, this is always greater than or equal to 2 times the square root of 2 power sine x plus cosine x. Okay, so now I'm going to use the fact that the minimum value of sine x plus cosine x is negative root 2. Okay, so that should pretty much work, which means that the minimum value of 2 power sine x plus cosine x should be 2 power negative square root 2. So this is also greater than or equal to 2 times the square root of 2 power negative square root 2. Wow. that's a lot of radicals. Okay, fine, so that should be the minimum value, no problem. Just move on. And yeah, this equality happens when both of them are equal, right? So 2 power sin x is equal to 2 power cosine x, which means that sin x and cosine x should both be 1 by root 2 in that case. And yes, that does work. I think not 1 by root 2, these should be negative 1 by root 2. Alright, so these should be negative 1 by root 2, and then this works, no problem. Okay, just delete this. Let's go to the next question, which is, if a squared plus b squared plus c squared is equals to x squared plus y squared plus z squared, and that is also equal to 1, then show that ax plus by plus cz is less than 1. Oh, okay. Mm-hmm. ah I'm going to do it like this. So I'm going to add this, right? So that will give me a squared plus x squared upon 2 plus b squared plus y squared upon 2 plus c squared plus z squared upon 2. That should be equal to 1, right? Because look at that, this thing, there's a squared plus b squared plus c squared, that is 1. This thing is also 1, and then you got 1 plus 1 is 2 divided by 2, that should be 1 once again. So yes, that's very nice, because we have some AMs over here, and then we can use AM greater than or equal to GM on that. So this is going to be like 1 is greater than or equal to, you have a squared plus x squared. Okay, so the GM of those two is going to be square root of a squared into x squared is like ax, and then you have by, and then you have cz. Okay, so we had to prove that this is less than 1, but what we proved was that this is less than or equal to 1. So it will be completely less than 1 only if yeah, only if like a and x are equal, b and y are equal, and c and z are equal. Wow, that's weird. Fine, so this equality happens only when a and x are equal, b and y are equal, and c and z are equal, which I don't think is going to happen very often. So yeah, this does work. Okay, so the next question is, if a b c are real numbers such that 0 is less than a is less than 1, and 0 is less than b is less than 1, and 0 is less than c is less than 1, and a plus b plus c is 2. Okay, then prove that, there's some other thing, then prove that a upon 1 minus a into b upon 1 minus b into c upon 1 minus c is greater than or equal to 8. Oh, okay. What do we do? Never seen something like that, huh? We can surely use that 1 minus a, that is going to be b plus c minus 1. No, that's not a good thing to do. What can we do with this? All we know is that a plus b plus c is equals to 2. There has to be something which we can do. Okay, and a, b, c are positive and less than 1. Fine, so 1 minus a is positive, 1 minus b is positive, 1 minus b is positive. No problem. But then how do we make it happen somehow? I don't know, there has to be something I can do. It has to be greater than or equal to 8. Well, 1 minus a can sure be written as b plus c minus 1, but that won't give me anything. Maybe we should try taking the reciprocal of these. Yeah, maybe we should try doing that. Okay, so that will give me like 1 minus a upon a into 1 minus b upon b into 1 minus c upon c is less than or equal to 1 upon 8. Okay, so what can we do with that now? Okay, this is obviously some kind of GM. Okay, yeah, we will have to deal with cube roots and stuff. Yeah, so maybe we can use that. We can use GM is greater than or equal to HM over there, because oh yes, we can use that, no problem. Oh, that is simple, so simple. Oh man. Okay, so the way we do that is that we take a cube root on both sides, so that will basically give me, and then this 1 minus a upon a, that can be written as 1 upon a minus 1. Oh wait a second, 1 upon a minus 1. I'm not sure that this is correct. You got a plus b plus c equals to 2, but about that I do not know. Oh, can't believe it. Nothing is working out. Huh? This is supposed to be some kind of an AM, okay. And then this is supposed to be some kind of GM, right? But 1 upon E, that's not correct. That is not correct. We are doing it incorrectly. Okay, we have to find some other way of doing it. A upon 1 minus B into B upon 1 minus B into C upon 1 minus C is greater than or equal to 8. Okay, let's just use GM is greater than or equal to HM for some while. Maybe that will give me the answer directly. So GM of these, okay, so that's going to be like the cube root of A upon 1 minus A into B upon 1 minus B into C upon 1 minus C. That should be greater than or equal to the cube root of 8, which is 2. Okay, so this is the GM of A upon 1 minus A, B upon 1 minus C, and C upon 1 minus C. Now this should be greater than or equal to their HM, so this should be greater than or equal to their HM, which is 3 upon 1 upon, I mean the reciprocal of that, which is 1 minus A upon A plus 1 minus B upon B. Okay, oh shit, this is not working very well. Plus 1 minus C upon C. Oh god. That's not nice. I don't think that's nice. Not gonna work. But let's just see what happens. So this is gonna be greater than or equal to 3 upon yeah, you got 1 upon A plus 1 upon B plus 1 upon C, and then you got you got this thing, this is plus 3. Alright, so you got plus 3 as well. Yeah, that, no, sorry, not plus 3, it's supposed to be minus 3. Okay, so this thing upon, like, okay, minus 3, nice. So that's how we do. Okay, fine. So this thing is like, we can write it as the HM of something. Okay, yeah, fine. So what do we know? We know that suppose this is like, okay, that won't work. We want this to be the harmonic mean of something. Yeah, so 1 upon, oh god, why is this not working? There has to be some way to make it work. Yeah. When you got A plus B plus C plus, okay, A plus B plus C equals to 2, how do we utilize that? I don't know. I don't know how to do it. Well, this is definitely greater than A plus B plus C, which is like 2, but 2 minus 3 is just, that's not nice. Okay, what about considering this as a harmonic mean? I mean, this does look like a harmonic mean, I guess. So we know that 3 upon 1 upon A plus 1 upon B plus 1 upon C, that is the harmonic mean of something, right? That's the harmonic mean of A plus B plus C. This is less than or equal to A plus B plus C upon 3, but this thing is just 2, so this is less than or equal to 2 by 3. Okay, so 1 upon A plus 1 upon B plus 1 upon C will be greater than or equal to 9 by 2. This is not giving me anything. No, this does not work. This just doesn't work. Okay, right, that's not the way to go. We have to find some other thing which might work. A upon 1 minus A. How can we write it? Maybe we write it as 1 minus A plus 2 times. No, that's not nice. Maybe like A minus 1 plus 1. So nope, not nice. Oh no, I'm losing patience. I don't know how to do it. Okay, we will just go back to this question after we have done the other ones. I'm pretty sure that this question does have some very easy solution, but I'm just not able to get that. Let's go to the next question, which is, in triangle ABC, prove that tan A plus tan B plus tan C is greater than or equal to 3 square root 3, where ABC are acute angles. Okay, fine. So in triangle ABC, prove that tan A plus tan B plus tan C is greater than or equal to 3 square root 3, where ABC are acute angles. Shouldn't be too bad, huh? We know that tan A plus tan B plus tan C is going to be greater than or equal to... No, that won't work. Oh, actually this can in fact work, because we know that in triangle ABC, tan A plus tan B plus tan C, this thing is also equal to tan A times tan B times tan C. Yeah, that's like a characteristic property of any three angles which add up to 180 degree. Okay, that's nice. So we can use a lot of stuff over here. So we can use am greater than or equal to gm on this. So that will give me that this thing is also greater than or equal to the cube root, okay, 3 times the cube root of tan A, tan B, tan C. But now we can make a substitution that this thing is equal to that thing. So this is actually greater than or equal to 3 cube root of the same thing, which is tan A plus tan B plus tan C. Okay, and then we can divide by this thing on both sides, because it's going to be a positive quantity, because it's an acute angle triangle. Okay, so that will give me yeah, so this will be, okay, 1 minus 1, that is 2/3. So tan A plus tan B plus tan C to the 2/3 power is greater than or equal to 3, right? So yeah, just raise this to the 3/2 power. So 3 to the 3/2 power is 3 square root 3, which is exactly what we had to prove. Yes, that's easy. Let's go to the next question, which is, okay, in triangle ABC, prove that cosec A by 2 plus cosec B by 2 plus cosec C by 2 is greater than or equal to 6. Okay, fine. So cosec of A by 2 plus cosec of, okay, that's going to be 1 upon sine of A by 2, 1 upon sine of B by 2. That should be greater than or equal to 6. Okay, that's nice. Maybe we can use am greater than or equal to hm over there. Yeah, that does work. That can work very nicely. So 1 by sine of A by 2 plus 1 by sine of B by 2 plus 1 by sine of C by 2 upon 3. That's the am of these things. This should be greater than or equal to 3 upon the sum of the reciprocals, which is sine of A by 2 plus sine of B by 2 plus sine of C by 2. Okay, so that's nice. What can be the minimum value of this guy? Yes, sine of A by 2 plus sine of B by 2 plus sine of C by 2. That thing can be written as 2 times the sine of, you got A by 2 plus B by 2 and the half of that. So A by 2 plus B by 2, that's going to be nothing but pi by 2 minus C by 2. Okay, it's going to be sine of pi by 4 minus C by 4. Okay, fine. And then cosine of, I'm not very sure where we are going with this. Just like cosine of the difference, no problem. Just the problem is like this might not work so nicely. Yeah, okay, I think we should not be using am greater than or equal to hm, but am greater than or equal to gm over here. Okay, we should be using that thing. So it is greater than or equal to the cube root of yeah, so 1 upon sine A by 2 sine B by 2 sine C by 2. Now we need to find the minimum value of that guy. Okay, fine. So sine A by 2 into sine B by 2, this thing can be written as, okay, so this can also be written as 4 upon 4 of that. Okay, nice. So this is going to be 2 into, you got 2 sine A by 2 sine B by 2 Well, that's just cosine of the difference, which is cosine of a by 2 minus b by 2 minus the cosine of the sum, so cosine of a by 2 plus b by 2, and then there's this sine of c by 2 over there. Okay, um, fine. What can we do with that? Just erase some. Just minimize this. Okay, that's nice. What do we do with that? Got 2 cosine of a minus b by 2. Okay, a by 2 minus b by 2 minus cosine of a by 2 plus b by 2, and then that all into sine of c by 2. Cosine of a by 2 plus b by 2, that is the same as cosine of pi by 2 minus c by 2, which means that this is actually the sine of c by 2 thing. Okay, so that will give me 2 sine of c by 2 into cosine of a by 2 minus b by 2 minus sine of c by 2, no problem. And then what can we do with that thing though? Cosine of a by 2 minus b by 2, well, that can be written as, okay, a by 2 minus b by 2. Oh, that's weird. Can we write it as something? Not sure. I'm not sure. What can we do with that? Sine of c by 2, you got that thing. Then maybe we can transform this c by 2 into a by 2 plus c by 2. Well, that might work. Yeah, so that can work, no problem. So that will give me cosine of a plus b upon 2. Oh yes, that can work, in fact. So this thing is going to be 2. You got sine c by 2, which is the same as cosine of a by 2 plus b by 2, just like we did over here. So a by 2 plus b by 2. You got cosine of a by 2 minus b by 2 as well. And then you got this thing, which I'm going to write it like minus 2 sine squared of c by 2, no problem. So now let's simplify it further. So this thing is going to be so it's 2 cosine of something times the cosine of some other thing. That's going to be the cosine of the sum, which is a, plus the cosine of the difference, so plus the cosine of the difference, which is b. Okay, and then minus 2 sine squared of c by 2. If you add 1 to that, that will give me cosine of c. Okay, so plus cosine of c, but now we need to subtract that one as well. Okay, fine. So this thing is cosine of a plus cosine of b plus cosine of c minus 1. No, that's fine, but that didn't give me the minimum value, so we are still stuck. Yeah, we are still stuck. That is not nice. Okay. Well, what do we do? This is not working very nicely. We do know that the minimum value is obtained only when all of the angles are 60 degrees, but I don't want to do that right now. Yeah, maybe we should be doing that. Okay, fine. So maybe we should be doing that, no problem. No need for all that stuff. Let's just go with logic this time. So we know that this equality happens only when all of these are equal, right? Which means that 1 by sine a by 2 equals to 1 by sine b by 2 equals to 1 by sine c by 2, which means a equals to b equals to c, and thus all of them are 60 degrees, which means that 1 upon sine of a by 2 is 1 upon sine of 30 degrees, which is 2. Okay, so you got 2 plus 2 plus 2, that is 6, right? So that's it, that's the answer, that this is always greater than or equal to 6. Easy as that. I don't know what's going on. Okay, that's it. This is equal to 6, no problem. Though this is not very nice, but what can we do with that? Fine. So this so-called minimum value is obtained only when all of these are equal, and which means that this thing is automatically greater than or equal to 6, because the minimum value is obtained when all of them are equal, and then that makes it 6 as well. So yeah, okay, fine. This was like a very lengthy question, so I'm not going to do that. I don't think I will be proving that soon. Okay, so you got a equals to b equals to c. Wait, sorry. Okay, so if ABC are the sides of a triangle, then the minimum value of a upon b plus c minus a plus b upon c plus a minus b plus c upon a plus b minus c is equal to, okay, then the minimum value of this thing is equal to b plus c minus a upon a. Okay, fine. And these are like the sides of a triangle. No problem. Can't believe this. So fine, we are going to use the same logic that whatever inequality we use, we get that minimum value only when all of these are equal. So if all of these are equal, that would mean that eventually a, b and c should also be equal. uh, yeah, which means that this thing is just 3. Okay, so like, yeah, the minimum value of this thing is equal to 3. That's it, no big deal, huh? Fine, so this is equal to 3. I know it's frustrating that we're basically using a very bad kind of logic over here, but I think there is no other way to get around this fast. Okay, so basically we are using the logic that whatever inequality we use am greater than or equal to gm. We use any other inequality. uh, that inequality is only an equality if, I mean, and when it is the equality, that is the case when you have the minimum value. So that can happen only if all of these are equal. Okay, all of these positive numbers are equal, which, yeah, which basically means that a, b and c should be equal, which means that this is automatically 3 without any further application of inequalities. That is it. Okay, so if a, b, c, d belong to a real, okay, belong to positive real numbers except 1, then the minimum value of log base d of a plus log base b of d, okay, is, that's easy. So this thing can be written as natural log of a upon natural log of d, and then the next thing can be written as natural log of d upon natural log of b plus natural log of c upon natural log of a plus natural log of b upon natural log of c, and then this is going to be greater than or equal to 4, and then the fourth root of their product, which just turns out to be 1. So yeah, this is always greater than or equal to 4, no problem, easy as that. Let's go to the next question, which is that if abc belong to positive real numbers, then bc upon b plus c plus ac upon a plus c plus ab upon a plus b is always, oh yes, this is basically just the application of some hm less than or equal to am inequality thing. Okay, fine. So what do we got over here? We got this thing, so a by 2 plus e by 2. Yeah, so obviously option a is correct, using hm is less than or equal to am, right? So these are basically, these things are hms of, well, you got a and b, and then b and c, and then c and a, whatever. So we're just using an inequality, we can get this thing. And then what else can we do? Well, c is obviously not correct. No, I'm not doing that right now. So it's not less than or equal to 1/3 of that thing. Okay, b says that it is greater than or equal to 1/3 of square root of abc. Well, you got something like, that's an hm, man, that's an hm. How can you do something like that? and HM is never greater than or equal to GM. Okay, so what was the application over there? Why is this greater than or equal to? Okay, that's it. That is it. No other option is correct. Nope. So yeah, that's the only correct option. So to the next question. So if ABC belongs to real numbers, which is positive real numbers, okay, then A plus B plus C into 1 upon A plus 1 upon B plus 1 upon C is always greater than or equal to 12, greater than or equal to 9. Yeah, just use AM greater than or equal to GM on this, so this will turn out to be greater than or equal to 3 cube root of ABC, and this will turn out to be greater than or equal to 3 cube root of 1 upon ABC. So yeah, it's going to be greater than or equal to 9. That's easy. Let's go to the next question. So if ABC belong to real numbers, okay, positive, okay, so positive real numbers, fine, then the minimum value of A times B squared plus C plus B times C squared plus A plus C times A squared plus B squared is equal to, just hate it. Okay, fine, it's basically once again some kind of application of that. Okay, so use AM greater than or equal to GM on that. So this will give me 2 times of BC, that will give me 2 times of AC, and that will give me 2 times of AB. So basically you got 6 times of ABC, no problem. So this is always okay, the minimum value of this thing is always equal to 6 ABC, no problem. Okay, if ABCD are positive real numbers and ABCD are in harmonic progression, then okay, these are in harmonic progression. Oh shit, which means that 1 upon B plus 1 upon C is equal to 1 upon A plus 1 upon D, I guess. Yes, no problem. Then you got A plus D is greater than or equal to B plus C. Okay, A plus C is greater than or equal to B plus D. uh, wow, A plus B is greater than or equal to, well, that's weird. These are in a harmonic progression, right? It shouldn't be working like that. I guess we have to do it differently this time, I guess. So the difference is going to be equal. What is this? Okay, so you got 1 by B minus 1 by A equals to 1 by C minus 1 by B equals to 1 by D minus 1 by C. Maybe we can do something with that. Yeah. So what do we do? There has to be something which we can do. You can share pair up A and D and B and C, no problem. And then these are positive real numbers. Okay, fine. And ABCD are in a harmonic progression. How do we know which of them is greater and which of them is smaller? Yeah, I mean, right, there is just no scope of knowing that, except if you are taking pairs. In that case, yeah, so pairs which cannot be reflected in those two numbers, and there exists only one pair like that, which is AD and BC. Okay, so we have to use something with that thing. Okay, fine. So you got A plus D is greater than B plus C, something like that, and then A plus C is greater than B plus D. And A plus B is greater than C plus D, something like that. Fine. So 1 upon D minus 1 upon A is going to be 3 times 1 upon C minus 1 upon B. That's not a good thing to do. So there is only one thing which we can use right now. 1 upon A plus 1 upon D equals to 1 upon B plus 1 upon C. There is no other alternative to use. But what can we do with it? Well, you can apply harmonic mean is less than or equal to arithmetic mean, but that won't give me anything. Alright, so that won't give me anything. Or maybe we can do it like that yeah, that can work, but I don't think that's gonna work. So a plus b is greater than c plus d. You got a plus c is greater than b plus d. Just look at something with a plus, yeah, so a plus d is greater than b plus c. So got a plus d, that should be greater than b plus c. You know that these are in harmonic progression, all right, and you know this thing happens. Yeah, what can we do with that? Not b plus c over there. Oh, come on, you got to think of something. Okay, let's just start expressing everything in terms of something like only two quantities, something like that. Maybe that will work, maybe that won't work, who knows. Okay, we could be doing that. So we could be doing b equals to reciprocal of 1 by a plus some difference, and then c equals to that thing, and it's gonna take a lot of time. We have to prove this fast, I guess. So a plus c is greater than b plus c. Sure, you have a plus d. Okay, so a plus d is equals to ad upon bc into b plus c. If we can somehow prove that ad upon bc of b plus c, okay, ad upon bc should be greater than or equal to 1, then we are done basically. Yeah, basically then we are done, no problem. But I don't think that's very easy to do. Okay, what do we have? Fine. So what we have to prove is that AD upon BC is greater than 1, which means that AD should be greater than BC. Uh, that's not super fine. I don't know how we're going to do that. Okay. Uh, how do we prove that, man? How do we prove it? AD should be greater than BC. Sorry. Yeah, we still are stuck on this. Let's just go and do some other questions. Maybe we will get some idea of how to do these questions then. Okay, so if a, b, c and d belong to positive real numbers and a, b, c, d are in a harmonic progression, then a plus d is greater than b plus c. Oh well, that's the previous question, no problem. So the next question is, if a, b, c are positive real numbers such that a plus b plus c equals to 18. Okay, a plus b plus c equals to 18, then the maximum value of a squared b cubed c power 4 is equal to. So yeah, that's a nice one. I know how to do it. Okay, so a squared b cubed and c power 4. Fine, so we can write it like this. We can write it as a by 2 plus a by 2 plus b by 3 plus b by 3 plus b by 3 plus c by 4 plus c by 4 plus c by 4 plus c by 4, that is equal to 18. Okay, so now let's just divide this by 1 2 3 4 5 6 7 8 9 of them, so that will give me 2 over here. Okay, and then this thing is greater than or equal to the ninth root of the product of all these, which is going to be a squared by 4 into b squared by 27 into c squared by 4 to the 4th power. Wow. Okay, oh no, c to the 4th power and then b to the 3rd power. Some problem. Okay, fine. And then 2 is greater than or equal to this thing. So let's just raise this inequality to the 9th power, so that will make 2 to the 9th power is greater than or equal to a squared b to the 3rd power c to the 4th power upon you got 4 to the 5th power, which is 2 to the 10th power, I guess. 2 to the 10th power, 2 to the 10th power times 27, something like that. Fine, I guess it's correct, no problem. Yeah, there should be no problem with this. You got 1 by 4 to the 4th power. Yep, everything is working perfectly, right? So then the maximum value of this thing, that will be equal to, you got 2 to the 19th, 2 to the 19th, and then into 27. So 2 to the 19 into 3 cubed. Yeah, here it is. That's easy, no problem. Just delete that. Okay, so the next question is, if f of x is given by x minus 2 into x minus 1 upon x minus 3 for all x greater than 3, then the minimum value of f of x is equal to. So because x is greater than 3, we have that these brackets are basically positive numbers. Okay, uh, then the minimum value of f of x is equal to, so I'm going to use the following, that x minus 3 can be written as x minus 2 plus of x minus 1, which is obviously greater than or equal to 2 square root of x minus 2 into x minus 1. Okay, no problem. So what can we do with that? We can basically square this, no problem with that, but not sure that's going to be a nice thing to do. Yeah, nope, that might not be nice to do. Okay, what else can we do with that? You can show that it as, you can in fact decompose it, but no, that is not a good thing. Yeah, fine. So you can write it as a harmonic mean. Linear value of f of x is equal to, okay, shit, this is not working very well. Oh, here it is. I know this can be done like that. Okay, so this can be written as so this can be written as x minus 2 plus x minus 2, but upon 2 plus x minus 1 upon 2 into x minus plus x minus 1 upon 2. Okay, this is going to be greater than or equal to 4, and then the fourth root of, no, this does not work, this does not work as well. I don't know why this is not working. You still have the same thing, you got the fourth root, that does not give me anything. Yeah, just delete that. That's not going to delete. Okay, so you have to find some other way of doing it. I initially thought maybe that we should use, I don't know, something like harmonic mean. Okay, that could have worked, but I don't think it's nice to do. I don't know, what do we do with this? You got x minus 3 over there. Maybe we can convert this into a polynomial. Yeah, that will basically do it. So suppose you set x minus 3 to be equal to u, which turns out to be a positive number, then you can write it as u plus 1 into u plus 2 upon u, right? So that will be equal to u squared plus 3u plus 2 upon u. That's going to be equal to u plus 3 plus 2 upon u. Oh, okay, that's doable, because look at that, u plus 2 upon u, well, that's nothing but 3 plus, okay, u plus 2 upon u, that's going to be greater than or equal to 3 plus 2 square root of their product, which is going to be 2. So yeah, so 3 plus 2 square root 2, that's it, that's the minimum value. So we just mark that out, 3 plus square root 2, I mean 3 plus 2 square root 2. No problem, let's go to the next question. Oh, so here's the next question. If a is greater than 0, then the least value of a to the third power plus a to the second power plus a plus 1 is, okay, then the least value of this thing is, okay, fine, 64 a squared 16 a power 4 plus 16 a cubed. Okay, basically we can use that am greater than or equal to gm thing over here. Yeah, that will basically give me the answer. That should work. So we're going to use that thing, and that will give me what have we got? Yes, it's going to be greater than or equal to the square of something, but you got how many? 4 terms. So the fourth root, oh yeah, and 4 times the fourth root, 4 times the fourth root of the product of these, which is going to be a to the 3 plus 2 plus 1 plus 0 thing, that turns out to be 7. Okay, so that's not working. It is, nope, not nice. You don't have an even power over there. 3 plus 2 plus, oh no, no wait, it does work, no problem. You got something like 3 plus 2 is 5 plus 1 is 6 over there. Yeah, no, 7. No, 7 is not correct. Fine. So this is going to be like 4 square root of a to the 3, and then the square of that, 7 is 16, a to the third power. Yeah, easy as that. 16 a to the third power. Go to the next question. This might be multiple choice. I don't care. I don't care about that. A rod of fixed length k slides along the coordinates, and if it meets the axis at a comma 0. Oh, so a rod of fixed length k slides along the coordinates. Okay, along the coordinate, I don't know what you mean. Oh, okay, slides along the coordinate axes. Yeah, so here are the axes. You got a rod of length k over there. Okay, if it meets the axes at a comma 0 and 0 comma b, okay, then the minimum value, wait, is this minimum or maximum? I think it's maximum value. No, wait, minimum value. Okay, minimum value of a plus 1 upon a squared plus b plus 1 upon b squared. Oh, fine. So it meets the x-axis at a comma 0, and then the y-axis at 0 comma b. Okay, and then this length is fixed. This is k, which means that this length is obviously a, this length is b. So you got a squared plus b squared is equals to k squared. No problem. Okay, fine. Then we have to find the minimum value of this thing, a plus 1 upon a squared plus b plus 1 upon b squared. No problem. So you got a squared plus b squared over there. You could do it like that as well. I mean, this is supposed to be greater than or equal to 2 square root of ab. Well, that will work only if a and 1 upon a are equal, which means that they have to be 1 and b has also to be 1. So that will give me k equals to square root 2. This is not correct. This might be correct. Yeah. I mean, you got 4 plus 4 is 8. Fine. But we don't know. Maybe like that fixed length k is not equal to square root 2. So this can never happen. Yeah, we do not know that. And then you got this polynomial thing. So let's just see what we get. So if we expand this, we will get a squared plus b squared is k squared, plus 2 is 4, and then plus 1 upon a squared plus 1 upon b squared. Okay, that's going to be like k squared upon a squared b squared, I guess. Yeah, I guess so. That does work. And then fine, and then you got it as ab over there. So you got k squared over there, and then you got 4 upon k squared. Not sure where we are going with this. It can be greater than or equal to. Okay, so that can be greater than or equal to. Oh yes, that can work. So you know that if you divide this by 2, okay, so 1 upon a squared plus 1 upon b squared divided by 2, that's going to be greater than or equal to 2 upon the reciprocals, like a squared plus b squared thing. That thing is just k squared. So this thing is always greater than or equal to 4 upon k squared. So nice. But once again, this only happens when a and b are equal. And that can happen, in fact. Yeah, that can happen, no problem. So yeah, k squared plus 4 upon k squared, no problem. I think these two are correct, though I am very doubtful about this one, but yeah, it should work. Let's delete that and let's go to the next question. Okay, so the least value of 6 tan squared phi plus 54 cot squared phi plus 18 is, no problem, because tan square and cot square are reciprocal, so we can use m greater than or equal to gm, right? So fine, no problem. So this thing is going to be greater than or equal to, you got 2 square root of 6 into 54, and then that tan square phi and cot square phi, those will get cancelled, and then you got plus 18 over there. Okay, is equal to, what is that equal to? 2 square root of, you got 9 into 6, I guess. You got 9 into 6 squared. This is just 3 squared. So 3 into 6 is 18. So you got 18 into 2 is like 36. 36 plus 18 is going to be 54. Right, that's it. 54. When am greater than or equal to gm is applicable for 6 tan square phi and 54 cot square phi. Yeah, so this looks correct. 54 when a greater than or equal to gm is applicable for 6 tan square phi, 54 tan square phi, and 18 is added further. Yeah, I mean, I could in fact write it like that as well, that I could have included 18 inside that. So no, that will give me something like a radical. Yeah, not a good thing. Cube root of something and then some other stuff. Okay, like the cube root of 3 times the cube root of 6 into 54 into 18. Once again, 6 into 54 is nothing but 9 squared into 6 squared. Okay, so that is, okay, 9 into 6 squared is like 18 squared, and then you got 18 over there. So oh yes, this is still correct, no problem. 78 when tan square phi equals to cot square phi. So which means that both of them are equal to 1. In that case, you got 6 plus 54 is 60 plus, yeah, that's nice, that is correct. Yeah, no problem. 1 is correct, 2 is correct. 54 when a greater than or equal to gm, and 18 is added further. Yeah, both of them work, and both of them do work, no problem. Like 18 into 3, there is going to be 3 and 24, 54. Nice. 1 is correct, 2 is correct, 1 and 2 are correct, and 3 is correct as well. I think 3 is not correct because 78 is not the minimum value, right? So I think all of them should be correct, but we'll just leave it like that. Fine, delete that. Let's go to the next question. So if a b squared c cubed and a squared b cubed c power 4 and a cubed b power 4 into c power 5 are in an AP, okay, and a b c are positive, then the minimum value of a plus b plus c is, these are in AP. Oh, okay, that's fine. Then the minimum value of a plus b plus c is, oh god, that can be pretty harsh. Okay, these are in AP, which means that 2 times of this, which is 2 times of a squared b cubed c power 4 is equals to a b squared c cubed plus a cubed b power 4 c power 5. Just cancel out some stuff which is unnecessarily added. So you got c cubed cancel, you got a c over there, you got c squared over there. Okay, you got this a cancelled, square is off, and you got a squared over here. Then you got this b squared cancel, you got b over there, and you got b squared over there, which means that 2 times of abc is equal to 1 plus, yeah, it should be like that. Okay, 1 plus a squared b squared c squared. Wow, so that's nice. which means that a squared b squared c squared minus 2 times of abc plus 1 equals to 0, which is a perfect square. Look at abc minus 1 whole squared equals to 0, so abc equals to 1. That's it. That's the only piece of information which we got. So abc equals to 1. Then find the minimum value of a plus b plus c. Well, we know that a plus b plus c should be greater than or equal to 3 cube root of abc. Okay, but abc is just 1, so this should be greater than or equal to 3. Fine. Okay, if y equals to 3 power x minus 1 plus 3 power minus x minus 1, then the minimum value of y is, okay, then the least value of y is easily done. Okay, so 3 power x minus 1, set that to be equal to u, I guess. And then you got this thing, 3 power minus x minus 1. Okay, so 3 power minus x minus 1, that's going to be 3 power minus 2 minus of x minus 1, that's going to be 1 upon 3 squared, and then 1 upon 3 power x minus 1, so it's going to be 1 upon 9u. What we basically have to find is u plus 1 upon 9u, right? The minimum value of that guy, that's obviously greater than or equal to the equal to 2 square root of their product, which is 1 by 9. So that's it, 2 into 1 by 3, that's like 2 by 3, no problem. So the least value is 2 by 3. That's it. Okay, no problem. Let's go to the next question. Minimum value of b plus c upon a plus c plus a upon b plus a plus b upon c. Oh god, what is this thing? Okay, if a b c are real positive numbers is, oh that's weird. Oh, really? Wow. I guess I'm going to do it like this. So we could use that old-fashioned logic that all of them should be equal, or we could do it like this. So you got a upon b plus c. Well, that is obviously, well, you got less than or equal to things, so that won't work right now. No, it will work. So you will have this is greater than or equal to 2 square root of bc upon a plus it's gonna give me something like that, which is not very good. Got a plus b. Okay, I'm going to do it like this, I'm going to call that, I'm going to say that this is equal to a plus b plus c into 1 upon a plus 1 upon b plus 1 upon c, but you got extra 1 everywhere, so you got plus 3 over there, right? Yeah, it can be written, no, not plus 3, it should be minus 3, so my bad, it should be minus 3 over there, right? Because 1 upon a and a, that will give me 1, so, and then 1 upon b and b, that will give me 1, and then 1 upon c and c, that will give me 1, so you have to remove that constant, so you have to have minus 3 over there. Okay, so this is obviously greater than or equal to, you got 3 cube root of abc, and then 3 cube root of 1 upon abc. That's easy, it cancels, so minus 3, which is equal to 9 minus 3 equals to 6. Easy, very easy, no problem. So to the next question. So the next question says that if first and 2n minus 1th term of an AP, oh, that's not in our homework. Okay, sorry, let's go to the next question. Oh, so it's a passage based question, I guess. Fine. So for our problems 1 to 3, if the roots of the equation f of x equals to x to the 6 minus 12x to the 5th power plus b x to the 4th plus c x cubed plus dx squared plus ex plus 64 equals to 0 are positive, then which has the greatest absolute value, which has the least absolute value remainder when f of x is divided by x minus 1 is, okay, fine. Yeah, I think I have done this in class itself. Fine, we'll just do it once again. So what have we got? We have got an alpha plus beta plus gamma. Okay, it's like a sixth degree equations, you will have like 6 roots. So the sum of roots, that's equal to 12, and the product of roots, that is equal to 64. Okay, so if you take the sixth root of that, that will give me 2, and then if you divide this by 6, that will give me 2, which means that the am, that this thing is equals to am, and this thing is equal to gm. So you will have am is equals to gm equals to 2, and this can happen if and only if all of the terms whose am and gm is equal to 2 are all equal, and equal to 2 in fact. So yeah, basically there is only one root, which is 2, and by one root I mean it's a I think I think recurring root. Yeah, it's a root which got multiplied by itself a lot of times. I mean 6 times, and it gave us this polynomial, which means that this polynomial, this f of x, is nothing but x minus 2 to the 6th power. And just by comparing coefficients, we will be able to find b, c, and d. And I think when I did this, the one which had the greatest absolute value was d. I don't remember very nicely, but yeah, I think it was like that. So whatever, just move on. We can find the values of b, c, and d uh, using this thing, f of x equals to x minus 2 raised to the 6th power. And then we have to find the remainder when f of x is divided by x minus 1. We can use remainder theorem and just put 1 over here, so you will have 1 minus 2 raised to the 6th power, which is 1. Yes, so that does work. Let's go to the next question, which is another passage. Okay, so the equation x to the 4 plus ax cube plus bx square plus cx plus 1 equals to 0 has real roots a, b, c. Okay, a, b, c are non-negative. So and this this equation has real roots. Then minimum non. Okay, fine. Just extract some information from it. So you got that this equation has real roots. And a, b, c are non-negative. Okay, fine. A, b, c are non-negative. Wait a second. That doesn't make sense. A, b, c are non-negative, and still this guy has real roots. It's pretty obvious that 0 is not one of those roots, so maybe we can divide this by x squared and then make this into a quadratic. I don't know. This might work, might not work, but this has got real roots. So the minimum non-negative real value of a is. What can we do with that? This has got real roots. Well, that's pretty obvious that the sum of those roots, that's going to be negative. Okay. As sum of those roots taken 2 at a time, that's going to be positive. Product of those roots, that's just 1. Okay, fine. So the product of the roots is 1. Okay, so that. Okay, fine. So it has real roots, but it does not say it's like real positive roots. No. And by the way, wait a second. That can be nice. Oh really, that is very nice. Here's the deal. We know that all of these roots are supposed to be negative, because because if any of them were positive root, and that should be satisfying the equation. But if you put that in this equation and then abc are non-negative, that just doesn't make sense, because then the net value of this left hand side, that could be positive. So that's not correct, right? It is not equal to 0 in that case, which means that all of these roots are in fact negative. And then you got alpha, beta, gamma, delta, that is equal to 1. So the product of roots is 1. All of these roots are negative, and then the sum of these roots, that is equal to this thing minus a. Okay, so the minimum non-negative real value of a is fine, which means that a is the negative of this thing. So like a can be written as negative alpha plus negative beta plus negative gamma plus negative delta. Okay, which by the way is greater than or equal to 4, and the fourth root of the product of all these, because these are all positive numbers. That's nice. So 4 times the fourth root of the product, which is just 1. Okay, so a is greater than or equal to 4. That's it. That is it. The minimum non-negative real value of a is in fact 4. Yeah, and this happens only when these are all equal, right? Which is when alpha equals to -1, beta equals to -1, all of them are -1. Okay, that's nice. Similarly, you can use logic that this minimum value will be obtained only when all of the roots are -1 as well. Okay, and then similarly for C, no problem. This is, it's just basically the application of a greater than or equal to gm over and over and again. Yeah, so that's nice. That is nice. That'll be cool. So the minimum non-negative real value of b is, let's just do this. So for b, it's going to be two roots taken once. Okay, at pairs of roots, I think. Yes, alpha beta plus beta gamma plus gamma delta all the way. I think there can be 4. Choose 2 is 4 into 3 upon 21 is like 6 of them. Okay, so this will be greater than or equal to 6, and the sixth root of their product, which turns out to be 1. Okay, so the minimum non-negative real value of p is 6. Okay, minimum non-negative real value of c is, so now you have 4 choose 3 is still 4. Okay, nice. So for c, c is going to be greater than or equal to 4, and then the product, yeah, the product thing like 4 and the fourth root of 1 basically. That's easy. So c has the minimum value as 4. Let's go to the next question. Oh, another passage. Okay, so this passage says that a1, a2, an, okay, all the way till an are positive real numbers, and x1, x2, xn are also positive rational numbers. No problem. Then the weighted arithmetic mean. Oh, yeah. The weighted arithmetic mean a equals to x1 into a1 plus x2 into a2 all the way till xn into an upon x1 plus x2 all the way till xn. Is it geometric mean? Okay, fine. And the weighted harmonic mean is equal to this thing, and they satisfy this inequality. Equality holds if and only if a1 equals to, okay, that's just basically the introduction to weighted arithmetic means and geometric means and stuff. Okay, so let a plus b plus c be equal to 2 and 3x plus 4y plus 5z be equal to 5, where a, b, c and x, y, z are all positive. So the maximum value of a cubed, b cubed and c power 4 is, wow, huh, that's weird. Okay, so you got a plus b plus c equals to 2. You got a, oh, that's easy, no problem. So we know that we can write it as a by 3, but 3 times of that plus 3 times of yeah, b by 3 plus 4 times of c by 4 is equals to 2. How many terms are there? You got 3 plus 3 is 6 plus 4 is 10, so you should have 10, and then this becomes 2 by 10 as well. So this is the arithmetic mean of 10 terms, which is like greater than or equal to the 10th root of the product. Okay, you got 1 by 3 to the third power into 1 by 3 to the third power once again, and then 1 by 4 to the fourth power, and then you have this thing a cubed, b to the, what's this thing, b to the third power, and then c to the fourth power. Okay, fine. Yeah, now let's just raise this to the 10th power. Okay, fine. Yeah, so raise this to the 10th power, you will get 1 by 5 to the 10th power is greater than or equal to 1 by 3 to the 6th power times 1 by, it should have been 4 to the 4th power. Yeah, 1 by 4 to the 4th power, so like 1 by 2 to the 8th power. Then you got a cube, b cube, and c power 4. No problem. Let's delete that. Okay. Therefore, the maximum value of this thing is when you have a cube, b cube, c power 4 equals to 3 power 6 into 2 power 8 upon 5 power 10. That's easy. That is easy. 3 power 6, yeah, 2 power 8 is nothing but 4 power 4, so same stuff. Yeah, option A is correct. Yep, that's nice. Okay, so the next question says the minimum value of 1 by A plus 9 by B plus 36 upon C is the minimum value of that guy. I think we have to use something like A greater than or equal to HM on that thing. Yeah, so what can we do with that? 9 upon B, that should turn out to be B upon 9, but that's not nice. This is not nice. You have like one of those. Yeah, I don't know. There should be something which we can do over there. You got this thing. Well, by the way, we have already found out the maximum value of a cube, b cube, and a c cubed. So why not just find out the like the minimum value of that using that thing? Or we could use hm is greater than equal to, less than or equal to am, something like that. Something like that, fine. So consider that to be the harmonic mean of something. I don't know how to do it. 1 upon A plus 9 upon B. Oh god, how do we do it? You will have something like a reciprocal, okay, which is not good. Okay, that's not good. Then you got, yeah, that's a big problem. There has to be something which we can do, right? So you will have the reciprocals, and then it's gonna be like, no, wait a second, it's not that bad. I think I can use this. So we know that a plus b plus c equals to, wait, what? Yeah, a plus b plus c equals to 2. So that gives me that a plus you got b by 3 plus b by 3 plus b by 3 plus c by 6 plus c by 6, like 6 of them, that is equal to 2 as well. How many terms have you got? You got 3 terms, 6 terms, that's 9 terms, and then you got one more term. These are 10 terms. So just going to divide this by 10 and then divide this by 10 as well. This becomes 1 by 5 as usual, right? And you got, okay, 10 terms over there. Fine, so it's going to be greater than or equal to the harmonic mean. Well, the harmonic mean is going to be 10 upon the reciprocals, which is just 1 upon A, and then you got 3 upon B 3 times, that is 9 by B, plus 36 by C. Okay, fine. And this is basically what we want to find right now. So you will basically have 1 by 5 is greater than or equal to 10 upon this box. So that's nice. This becomes 50. Take the reciprocal, so you got less than or equal to, so 50 is less than or equal to this box. So the minimum value of this box is this 50 thing, right? This box is nothing but 1 by A plus 9 by B plus 36 by C. Basically what we have to find. Yeah, so the minimum value of this guy is 50. No problem. Okay, let's delete that. Okay, cool. So the next question is that, what's the next question? Okay, fine. So the next question is that the maximum value of 1 plus x, oh, okay, to the third power, and then 2 plus x to the fourth power, and then 4 plus z to the fifth power is we have got this thing 3x plus 4y plus 5z is equals to 5. Okay, so now we want to transform into this thing. I think we are going to do it like that. So what I'm going to do is that I'm going to add 3 to this, so that will give me 3 into x plus 1 plus 4 into y plus 2 plus 5 into z plus 4. That is going to be equal to, you got 3 plus 8, which is 11, plus 20. So like 11 plus 20 is 31. 31 plus what was already there, which was, where is it, uh, yeah, 31 plus 5 is like 36. No problem. Okay, that's nice. So how many terms are there? There are 3 plus 4 plus 5, so like 9, and 3 is, yeah, you got 12 terms over there, so you have to divide this by 12, and then you got 3 over there. So this is the am of some terms. This is obviously going to be greater than or equal to the 12th root of their product. Okay, which is basically this thing, 1 plus x to the third power, and then 2 plus y to the fourth power, and then like 4 plus z to the fifth power stuff. Okay, so yeah, the maximum value of this guy is going to be 3 power 12. That's nice. That is really nice. Yeah, that does work. Okay, so to the next question. Okay, so did I mess up on something? No, I don't think so. Yeah, it's correct. If a, b, c are three positive real numbers, then the minimum value of a squared plus 1 upon b plus c and plus b squared plus 1 upon c plus a. Oh, this is a different question altogether. Okay, how many other questions do we have? Oh, that's the last one. Just delete that as well. Okay, so if a, b, c are three positive real numbers, then the minimum value of, not delete that, maybe this will turn out to be handy. Okay, fine, delete that at least. Okay, cool. So you have a, b, c are three positive real numbers, then the minimum value of a squared plus 1 upon b plus c plus b squared plus 1 upon c plus a. Oh god, what is this thing? Okay, is, oh shit, this is very weird. We need to find the minimum value, right? So for minimum value you need to apply something like m greater than or equal to gm, maybe. Yeah, something like that. I don't know, I've never seen something like this ever. Your d squared by just 1, which is greater than or equal to 2 times of a. I don't know why I have some weird feeling about this. So taking the reciprocal, you will have that in the denominator. Fine. Then you can have a plus b plus c over there, and you got 1 plus a plus b and 1 plus c. Sorry. Okay, a, b, c are three positive real numbers. The minimum value of this guy is, this guy is obviously greater than or equal to 2a upon b plus c plus 2b upon a plus c plus 2c upon a plus b using AMGM. Okay, cool. But now where do we go from here? You got to have b plus c. I don't know, I've never seen something like this. Maybe like a upon b plus c. Okay, everything is symmetric over here. Wait a second, doesn't that look something like a harmonic mean? Yeah, fine. So it's like 6 into a upon a plus b plus c, then b upon a plus c, and then c upon a plus b divided by 3. That is the am, which will be greater than or equal to the hm. So 6 into 3 upon their reciprocals, which is like, oh shit, their reciprocals are even worse. Okay, so b plus c upon a. Maybe we should add 1 to that, right? So let's add 3 to that, and subtract 3 at the same time. So we're going to subtract 3 and then we can factorize it. So a plus b plus c, then 1 upon a plus 1 upon b plus 1 upon c minus 3. Okay, that's nice. Greater than or equal to this guy. Yeah, what do we know? Uh-oh, this is not nice. This is not nice because we cannot use a greater than or equal to over there. That does not work. It's almost like the previous question, like the one which we couldn't do. Okay, so now we need to find some way to get around this. Look at the reciprocals, look at how it works. You got 2 upon it, and then that thing, that's you got 2a upon b plus c, and then plus 2b upon c plus a plus 2c upon a plus b, all that stuff. Okay, c plus b, a plus b, okay, sorry. But where do we go from this? There should be some way of solving it. What can we do? What can we do with this thing? You can obviously not apply the a greater than or equal to hm inequality directly. We have to find the minimum value, right? So we should prove that this is greater than or equal to something. All right, it could be that we prove this is greater than or equal to the gm. Not sure that will work. It's like, no, I don't think the gm will work. Nope. The hm could have worked, but no, that's not very nice. You got ABC over there, right? Hey, why don't we use that thing? Like, so we could equal to something. No, that doesn't work. What do we do? What do we do with it? You have B plus C. You do not want to completely simplify it. No, that's a bad way of doing it. What about we prove that the denominator is less than something? Maybe like, I don't know, something. Say, no, that is not working. Nothing is working. Why is it not working then? What about adding something? Maybe like, yeah, we could be adding something. And then this will be E plus C. Oh shit, that can be a very nice process of doing this. I can write it as a upon b plus c plus b upon c plus a plus c upon a plus b, just the half of that thing, plus you got all that stuff. Well, I'm going to subtract 3 from that. Okay, fine. Anyways, so subtract 3 from that, and you got plus. Here's when the actual logic comes in. You got a plus b plus c into 1 upon a plus 1 upon b plus 1 upon c. That is sweet. That is very sweet. And this thing is going to be greater than or equal to 3 cube root of abc, and then 3 cube root of 1 upon abc, greater than or equal to 9. So that's nice. So this complete thing, that will be greater than or equal to 6. Oh, and let's just call this thing as x. Okay, so you will have to call this as 2x. So you will have 2x is greater than or equal to x plus 6. Yes, that means that x should be greater than or equal to 6 as well. Wow, that is so awesome. I can't believe this. That is really nice. That's a nice way of doing this. Now we are ready to attack that question which we couldn't do. So the minimum value of this is in fact 6. So like is 6. That is nice. So now we are ready to attack the question which we couldn't do. Okay, just erase this thing. Okay, so let's see which question we couldn't do. Yes, let's go and see. Oh, that we could do, no problem. Which of them was like impossible? Yeah, this one, right? Yeah, this a upon 1 minus a thing, we couldn't prove that. Yeah, this is greater than or equal to 8. So that's one thing which we couldn't prove. What else could we not prove? This one, Okay, so we couldn't do the 7th one and the 17th one, so now we are going to try it once again. All right, so it's the 7th one and the 17th one. And well, where is that thing? I don't know. Just wait a second, just smart select something. Just hang with me for some time. Okay, it's Samsung Notes. Okay, cool. So where is that question? Let's just do it. Yeah, here's the 7th question. So you got a upon 1 minus a. Right, so you got a upon 1 minus a into b upon 1 minus b into c upon 1 minus c is greater than or equal to 8. And you got a plus b plus c equals to 2. We had to prove this thing. Okay, it's still not so cool. So you got 1 minus a upon not sure what we are doing with this. So you got 1 minus a. You could use something like the a greater than or equal to hm inequality, but that's not going to be a lot of nice thing to do, so that's not going to be nice. Yeah, so 1 minus a, consider that as the things. Yeah, like 2 minus of that thing. Oh, okay. Wait a second, it can be 2 minus of that thing, which is shit, that is 2 minus a. Wait a second. Okay, so 2 minus of 1 minus a is a, which means that 2 minus a is equals to 1 minus, but 2 minus a is b. Wait a second, so you're taking like 1 minus a equals to c. No, wait, that's not like that. So 2 minus a, why is this not working? Oh, it's because like it should be 1 minus a. Yeah, all right. Oh god, I can't believe that. So what about this thing? 1 minus a plus 1 minus b plus 1 minus c. It's going to be 1 as well. Oh, okay, that is it. So let 1 minus a be equal to x, let 1 minus b be equal to y, 1 minus c be equal to z. I don't know, that's a nice idea. Which means that x plus y plus z, that would be equal to 3. I don't see any resemblance with the previous question which we solved, but anyway, just freshened up. So now I got my creativity flowing. Okay, so no, x plus y plus z is going to be equal to 1, not 3. Okay, so now we can write this thing as, what can we write it as? We can write it as 1 minus x upon x into 1 minus y upon y into 1 minus z upon z is greater than or equal to 8. Okay, and where do we go from that? Got a over there and then stuff like that. Fine, it's gonna be 1 minus x minus 1. We could be doing that. So 1 minus x can be represents a. So you got a plus b plus c equals to 2 and x plus y plus z equals to 1. Okay, fine. What can we be doing with that? You got something like this. I think we have to go the harder way around this, which I really hate. I don't want to do that, but we got no other way of doing it, so it's going to go and do that, I guess. Yeah, or we could be doing like 1 by x plus 1 by x. It's still not nice. Oh, come on, can't believe that. It's like a plus x equals to 1 and then x plus y plus z, these add up to 1, and then I don't know how do we do it. Yeah, like a equals to sine square theta and this equals to that could be one of the things which we can do. That should be greater than or equal to 8, right? So you got that thing. Okay, come on, we have to think. What do we do with that? Yes, like 1 minus 5 the 1 minus, it's gonna be okay. We just have to do it the harder way, right? I know this sucks, but we got no other way of doing it, so let's just do it now. Just gonna minimize this. Okay, cool. So the harder way of doing this, like 1 minus x into 1 minus y into 1 minus z is equals to, I mean it's greater than or equal to 8xyz. Okay, so now we're going to expand this. Why? So it's going to be 1 plus xyz, and then you got, well, with this one you got y and z, so you got xy plus yz plus xz, this thing, yeah, uh, plus plus, no wait, not plus, I guess it's gonna be minus of x plus y plus z is greater than or equal to 8xyz, I guess. Yes, fine. That's what we want to prove. So x plus y plus z is just 1. That's nice. Okay, so it's like proving that this is greater than or equal to 7xyz. This thing is just 1, so this end just completely cancels. So basically what we have to put that is xy plus yz plus xz is greater than or equal to 7xyz, something like that. Okay, so I don't know what am I doing. Oh god, is this really supposed to be like that? We got xyz over there. It's supposed to be only one, and then one xyz, and then what else? Can't believe this. This is not working at all. And then you got this thing. We have to prove that x y plus yz plus xz is greater than or equal to 7xyz. That's not a nice thing. This is not a nice thing to do. Here's where the problem kicks in. It's supposed to be minus xyz. Okay, that makes sense. That why we are getting 7 over here. But 7 is not a good thing. 9 is. So you got 9. I mean 8xyz over here, and then here it will be 9xyz. Okay, so we have to prove this thing, that xy plus yz plus xz is greater than or equal to 9xyz. In other words, what we have to prove is, I think it's going to be fairly easy to do that this time. Okay, cool. Right, it's going to be very easy. Just look at that. You have, fine, so you have this thing xy plus yz plus xz is greater than or equal to 3 times the cube root of, wait a second, x squared y, well that won't work, that just won't work. Okay, so that's not the way to go. You should be thinking of some other way of doing it. Okay, so you got x squared y squared z squared, not a nice thing to do. Maybe we can do it like that. So if we divide this by x by z, that will give me 1 by x plus 1 by y plus 1 by z should be greater than or equal to 9. This shouldn't be too hard to prove, right? So we obviously know that x plus y plus z is equal to 1, which means that one third of that is 1/3. Okay, so this is the am of x, y and z. It's going to be greater than or equal to the hm, which is 3 upon 1 by x plus 1 by y plus 1 by z. Okay, so 1/3 is greater than or equal to 3 upon this thing. That is more like saying 1 by 9 is greater than or equal to 1 by x plus 1 by y plus 1 by z. If we take the reciprocal, that will give me, I mean the reciprocal of this thing. So 1 by 9 is greater than 1 upon 1 by x plus 1 by y plus 1 by z. If we take the reciprocal of this inequality, that will give me 1 by x plus 1 by y plus 1 by z is greater than or equal to 9. That's it. That's how we do it. Easy. That was nice. What other question could we not do? We did that question, then we also did this question. Yeah, is there something left which we couldn't do? Oh yes, that 17th one, right? This thing, that if a b c are real numbers, then the minimum value of, no wait, that's the 16th one, sorry. Okay, if a b c d are positive real numbers and a b c d are in a harmonic progression, then you got a plus b is greater than c plus d. Not sure that works that way. You also have a plus c is greater than b plus d. No, that's too symmetric to work in only one way. So the last one is like a plus d is greater than b plus c. We know that 1 by a plus 1 by b is going to be equal to 1 by b plus 1 by c. uh, I don't think that's the nicest way of doing it. We could be doing it differently, Okay, so suppose we consider that yes, it's 1 by a, 1 by b and 1 by c, these, and then 1 by d, these are supposed to be in a arithmetic progression. So why not consider that 1 by b is something like p minus q, 1 by c is p plus q, this is p plus 2q, and then 1 by a is p minus 2q. Okay, where p is strictly greater than q, I mean greater than 2q, sorry. So p is greater than 2q, and then you have this thing, right, corresponding to these numbers, and then we can take the reciprocal. So p is going to be 1 by p minus q, c is going to be 1 upon p plus q, and then a is going to be 1 upon p minus 2q, and d is going to be 1 upon p plus 2q. Okay, now let's look at a plus d. So a plus d, that will be, you have p minus 2q into p plus 2q, and then you have p plus 2q plus p minus 2q is just 2p, and then b plus c, that is going to be 2p on the top, and then you got p minus q into p plus q. Okay, so for both b and c and a plus d, you got 2p on the top. So when we compare them, just don't compare that thing, we have to compare the denominator in that case. And the denominator for b plus c is p squared minus q squared, for a plus d is p squared minus 4q squared. Which means the denominator of a plus d is less and still positive, which means that a plus d is going to be the greater quantity. So yeah, a plus d is going to be greater than b plus c. That is nice. This is really nice. Okay, so that's it. That was my homework. Thanks for watching.